good afternoon, good evening, good morning, good night. I don't know when you're watching, but thanks for watching. We are covering section 11.2, writing chemical equations from your CK12 packet. So let's start off our lecture today talking about how do you make shrimp gumbo. And shrimp gumbo is one of those Cajun dishes or cuisines that are famous in Louisiana. Okay, Cajun culture and Cajun food is very big in New Orleans and anywhere in Louisiana, just about everywhere you go. I'm not a big fan of Cajun food because it is very spicy, and I'm not a big fan of spicy food. But I will, steal a couple of pieces when my husband orders it. He loves spicy food. But either way, we need to talk about how do you make shrimp gumbo as part of our introduction for writing chemical reactions. Who's going to help?
Shrimp gumbo is one of many enjoyable dishes that are part of the Cajun culture in Louisiana. It's a spicy dish that needs careful control of all the ingredients so that it is a quick but is not overwhelming. Recipes tell not only what is in the preparation but describe how much of the ingredient and details of how to cook the meal. Similarly, with this type of information in order to carry out chemical reactions successfully and safely.
Right. Thank you so much. So, anytime you're cooking, it's like you're doing a chemical reaction, right? And most of the time it is an actual chemical reaction. The first thing you do was you gather your reactants. What are your ingredients, right? You're looking at the recipe. Okay, I need shrimp, I need sausage, I need pepper, I need what's that spice? I'm trying to think of it. Cayenne spice, right? To give it that kick. All of those are like gathering all of your reactants, right? Once you have the reactants, well, you mix them up in the appropriate amounts, and then you put it on the stove. And that's like the yield sign, right? That's when you know the chemical reaction is happening. And then after whatever time it says for you to put it on, you turn off the heat and you move it over and you let it sit, and now you have your final product. And man, that looks really good. Like, I'm not a big fan of gumbo, but really that dish looks so good. I love shrimp. So if they were to offer it to me, I would have been like, yeah, bring it along, but make sure you bring me a giant glass of water, because me and spicy food, whew, it's gonna take me a while and a lot of water to get through it. All right, so chemical equations. Chemical equations. We started talking about this topic yesterday. We started talking about word equations, and we said that word equations are time consuming to write. Right? You got to write every single thing. You need to write what state it's in, how it's reacting, if you added heat, and all of that stuff. But you got to remember that these word equations, they don't provide enough information that us as chemists need, right? I don't have the number of moles. I don't have how much product is being produced. There's still a lot of information that these word equations do not provide. Chemical equations. A chemical equation, you have to remember, is a representation of a chemical reaction that displays or tells us the reactants and the products with chemical formulas. So we're moving on. Yesterday was all about a word equation where we would have the names of the compounds that were reacting. Now we're moving on to the next step. Well, instead of the word or the name of the compound, now we're looking at the chemical formula for the compound, whether it's a reactant or whether it's a product. And yesterday, I believe we had the word equation for the reaction of methane with oxygen, right? We saw that word equation set up for us. And methane, the formula for methane is now shown, CH4. The formula for oxygen gas is shown, O2. And our products, carbon dioxide and water, we have the formula, CO2 plus H2O. Now, that equation has a name on its own. The equation below says that it's called a skeleton equation. It is an equation that shows only the formulas of the reactants and the products with nothing. There is no indication about how much of each is being produced or needed. The first step in writing an accurate chemical equation is to write the skeleton equation, making sure that the formulas of all the substances involved are written correctly. Remember, if you see prefixes, well, those prefixes are going to be changed into the subscript of whatever element it's connected to. If you have an ionic compound, you got to make sure that you have your ion sheet with those charges ready so that you can cross them down and have the correct formula, right? Different type of compounds have different type of rules. And we got to remember that, especially when we're doing this topic, because we're going to run into all types of compounds. We're going to run into ionic, we're going to run into covalent, we're going to run into acids, into bases, all of those type of compounds. So you got to remember all of the rules that we talked about at the end of December. All reactants are written to the left of the yield arrow, separated from one another by a plus sign. Likewise, products are written on the right side of the yield sign, and they are also separated by using a plus sign. It is often important to know the physical states of the reactants and the products in a hold on, did I skip something? I feel like I skipped something. Okay, it's next. Okay, here we go. It is often important to know the physical state of the reactants and the products taking part in a reaction. So why do you want to know if you're dealing with a solid? Why do you want to know if you're dealing with a liquid? Or why do you want to know if something's dissolved in an aqueous solution or water? Well, you need to make sure that your setup, right? If you're running an actual reaction, you need to make sure that, okay, I know that this guy, my reactants are gases, so I need to make sure my setup, my glassware, is able to hold on to that gas and not let it escape, right? If I let some of that gas escape, it's going to change my results. So you need to know what state your reactants and your products are in so that you don't lose any product or you don't lose any reactant that's going to change your results. Okay, that's very important. To do this, put the appropriate symbol in parentheses after each formula. Okay, so remember, if you see an S in parentheses, that just means that the compound is a solid. If you see an L in parentheses, that means the compound is a liquid. If you see a G within parentheses, that means your compound is a gas. And AQ in parentheses means it's an aqueous solution, means your substance is dissolved in water. Okay, so if we were to apply that to the reaction that we talked about earlier, which is methane reacting with oxygen, you would have both reactants as gases, one of your product as a gas, and the other product will be a liquid. Okay, and you can see them here. You got that G, 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 and L. Okay, everybody clear on that? Any questions on that? Why is it important? Because you need to make sure that you do not lose any reactant and any product to the environment because it's going to change your results. Excuse me for burping there. Okay, so here you have your first paired question. Add the appropriate symbols S, L, AQ, or G in between the parentheses for the following equations, okay? And they give you a word problem that goes with it, okay? So for number 1, it's going to go with this reaction. Number 2 will go with the bottom reaction. You are to read it out, the word problem, and try and figure out, okay, are they talking about a solid? Are they talking about a gas? Are they talking about a liquid? Or are they talking about an aqueous solution? All right, let's try it out. Number 1 says, iron metal reacts with oxygen gas to produce solid iron 3 oxide. What would you put in these parentheses, guys? Okay, what would you put in these parentheses? Would you put an L? Would you put an S? Would you put a G? Or would you put AQ? If it says iron metal reacts with oxygen gas to produce solid iron 3 oxide. All right, I got one person writing. Number 2, hydrogen gas reacts with oxygen gas to produce liquid water. Okay, I think number 2 is a little bit easier than number 1 because there might be one here that's a little bit confusing, but everything else, the state of the matter is in the name or in the sentence. All right. Very good. Very good. He got all they were able to get them, right? So if it says iron metal, you're more than likely talking about a solid, right? Anytime you have a metal and it's by itself, it's usually in the solid form. At least that's the way I've seen them. And then if it says reacts with oxygen gas, because it says it in the name. Oxygen gas is definitely going to be in the gas state. And then for the last one, iron 3 oxide, it says it in the sentence that it's in the solid form, so they put an S in here. Great job. Number 2, this person, it says here, hydrogen gas reacts with oxygen gas to produce liquid water. So hydrogen gas, the fact that it says gas definitely should have a G in here. The other one, again, it says oxygen gas, definitely should have a G in here. And then the last one, it's producing liquid water, well, definitely L. Really, really easy, okay? Excellent job, both of you guys. Great, great job, okay? Any questions on this one? Any questions on this problem? Pretty straightforward, right? Now, let's talk about this table. This table below shows a listing of symbols used in chemical equations. Some, such as the double arrow, which represents equilibrium, and the use of a catalyst in a reaction, will be treated in detail in other concepts. So they're not going to really go into detail about what equilibrium means. They're not going to go into detail about what a catalyst is, okay? I will give you the quick version, okay, just so that you know. All right, symbol number 1. If you look at symbol number 1, it's a plus sign, right? Everybody sees it here. This little plus sign is used to separate multiple reactants and or products. There we go. All right. If you see this arrow pointing to the left, it's known as the yield sign and it separates reactants from products. If you see a double arrow, right? An arrow pointing left and an arrow pointing right, that just means that and it replaces the yield sign, by the way. You will never have both. You'll either have the arrow pointing to the right or arrows pointing both directions. But if you see an arrow pointing in both directions, it's going to mean that you have a reversible reaction when you get to equilibrium, okay? Just know that it means it can go forward or it can go back. The next 4 we've already talked about, but I'm going to talk about them anyways. If you see S in parentheses, either a reactant or a product is solid. If you see an L in parentheses, either your reactant or your product is in the liquid state. If you see a G in parentheses, either your reactant or your product is in the gas state. And if you see AQ in parentheses, a reactant or a product is in an aqueous solution, which just means that it's dissolved in water. And the last, second to the last one, if you see a formula over the arrow, a formula written above the arrow is used as a catalyst in the reaction. So catalysts are those compounds that speed things up. If there's a triangle over your arrow, the triangle indicates that your reaction was heated. Okay? Any questions on the symbols? Any questions on the symbols? And remember, the formula can change because different compounds can be used or different elements can be used as catalysts. In this case, they're talking about platinum. Okay, but that's not the only one that can be used as a catalyst. There are other elements. Okay, so if you see a formula over this arrow, make sure that you remember that it's a catalyst, meaning it just speeds things up. All right, your second Pear Deck question is asking you to match the symbols to the correct description. All right, match the symbols, and you can draw lines that connect it. Just make sure you use the little skinny line, because if you use the big fat one or the thick one, it gets really jumbled up. Okay, so if you can change your line to the thin one and match them correctly, I'd really appreciate it. Go. Okay. They're still working, so let's give them some time. Oh. Of it. Are you guys ready? There's only 9 of them. Okay, very good. I love the use of colors. I love it when you guys use different colors. So much easier to read. They're almost done. I think they looked a little bit more than halfway done. So let's give them another minute or two before we start our discussion. Put in there your initials so I know who did what, and I can give you guys some credit. Almost done. I see only just one more. One more needs to be put in there. You're missing just 1 or 2 more. Let's give them 1 more minute to finish up. Ooh, what happened to Jeremiah? Oh God, I can't stop yawning. All right, let's discuss. Okay, so the plus sign is definitely used to separate reactants from products. The arrow is our yield sign. The double arrow is our reversible reaction symbol. S in parentheses means it's solid. L in parentheses means it's liquid. And G means that it's in the gas state. AQ is aqueous solution. Very good. That was pretty easy to see, right? And then anytime you have a formula over or under a symbol, that just means that it's a catalyst. It's speeding things up. And the triangle, it can be above or below, is an indicator that your reaction was heated. Very good, Miss Dominique. Dominique, or Diamante. Sorry. I have a Dominique in 4th period. Diamante. Sorry. Okay. Very, very good. Look at them. They're doing it in speed lightning. Very good. Thank you, those of you who are participating. I appreciate it. All right, let's move on. Let's finish up. A video. I already have the video ready to go. At least.
Hey, this is Miss Dora. Today we're going to be talking about chemical reaction.
And we're only going to see about half of it, okay? I don't want to run out of time.
This picture is a picture of a chemical reaction. They're not all this glorious, but that sure is a pretty one. Today I want you to be able to write chemical equations from something called word equations. Stay tuned. Well, first of all, in order to write a proper chemical equation, you need to know some things about it. So you need to know that the reactants always are the starting materials, and that those always go on the left. And the products are the end materials, and they go on the right. And in between them, you have an arrow pointing to from the reactants to the products. You also might have some symbols written after the formulas, and we're going to really put to use the nomenclature that we did writing the formulas from names. And so you may see a symbol after them like this little G, and that little G may be in parentheses like this, and all the rest of these may be in parentheses also. And that G means that it's in the gaseous state, and so you need to know that. The L means that it's in the liquid state. The S means it's a solid state, and the AQ is something maybe new to you. That means it is dissolved in water. That is called an aqueous solution. And that just means that something is dissolved in water solution. You're also going to see these terms that are on the right hand side. When you see the plus, if it's on the reactive side, it's going to mean reacts with. If it's on the product side, it's just simply going to mean and because it produces two different things. The arrow, it means produces or yields. Either one of those would work. If you see a triangle, and the triangle would usually be above an arrow, the triangle is going to mean that heat is added to it. And usually that's breaking something down, but the triangle just means that heat is added. And if you see a little chemical formula above the arrow, that means that this thing right here, the KCl, is a catalyst. And a catalyst, what that does, that takes part in the reaction, but it doesn't show up in the reactants or the products. It just helps the product or the reaction go a lot faster. Make sure you know these terms. Make sure you have them written down. So here's a sample.
So right now, those were all the symbols that we kind of already discussed. But this is what you're gonna soon be doing on your own, okay? And maybe not on your own. I'm always here. I'll guide you through it, but you got to remember some of those rules for writing formulas, okay? And he doesn't really go into the details to help you remember them, but he does mention them in passing, okay? And he starts talking really fast, so pay attention, guys.
Word chemical equation. It's given to you with the names, and we're going to actually write out the chemical equation with the symbols. And so it says that sodium metal. There are some terms that we understand here that we already know, like reacts with. We know what that means. To produce. We saw that on the last slide, but we have to add in some other things here. So sodium metal we need to start with, and so sodium metal is just sodium, Na. And it says, and we don't have to check the charges on it. That's all by itself, so it's just fine. Reacts with, we saw from the last page there, that is a plus. Chlorine gas. Now, chlorine gas, and by the way, sodium metal, we could add this in here. We won't add this all the time, but I'm going to add it for right now. I'm going to put a little S right there. Since it's a metal, it's a solid. So I'm just saying that it is solid sodium. And so when we see chlorine gas, we know that that's just Cl, but chlorine is one of those diatomic elements, which means it can't stand alone. So since it is by itself, it has to be Cl2. And Cl2 gas, I'm going to add this little thing right here, the little G. And then it says to produce. When it says to produce, we put an arrow pointing to the right. Solid sodium chloride. Now to write sodium chloride, we need to put Na and Cl, that's sodium and chlorine. Then we need to check the charges. That's right, that charge checking does not go away. Sodium has a plus one, chlorine has a minus one. In this case, it worked out. They cancel each other out. And we don't have to crisscross. It is a solid, so just for today, right now, I'm going to put a solid in there. And that is what we've just done right there. We've written something called a skeleton.
So anytime they say an element as a metal, it's always just the element by itself. If they say chlorine gas, fluorine gas, that's a diatomic molecule, means there's always going to be two of them. Whether if it says chlorine gas, Cl2. If it's fluorine gas, F2. If it says iodine gas, I2. And then sodium chloride, it's ionic. It's an ionic compound. Use ionic rules, meaning look up the symbol, look up the charge, cross them down, cancel them out, all of that stuff. Okay. It is going to come back, so you better be prepared.
And equation. The reason it's called a skeleton equation is because it's not a balanced chemical equation, which we'll get to a little bit later. It is just saying that these are the reactants. The reactants are right over here, and this is the product. You react those two, you're going to get NaCl. Now, this may scare you a little bit. You see that there's 2 chlorines here and only 1 over here. We'll take care of that later on. You just got to trust me on that one. All right, so I'm going to walk you through a couple more here. You're going to find out real quick that if you don't know how to write the formulas, you may want to go back and watch the video on that for binary ionic, binary molecular, and the polyatomics. You need to know how to write the formulas and check the charges. So you watch what I do here. You go along right with me. And so we have aluminum oxide. And so I'm just going to start with writing aluminum oxide. Aluminum is Al. Oxygen is O. But when I check the charges, that's right. Check the charges before we move on. Aluminum has a +3. Oxygen has a -2. They do not cancel, so I got to crisscross Al2O3. And then it says reacts with. So I got my aluminum oxide taken here. Okay, reacts with is plus copper 1 sulfate. Well, copper is Cu. Sulfate is SO4 with a -2 or a 2- charge. The copper has a +1 charge. The sulfate has a -2. So I have to crisscross down here. Cu2SO4. No parentheses needed. Got that taken care of. And then it says to produce. To produce means we put an arrow there. Aluminum sulfate. Now don't just copy over these little subscripts from one side to the other. We need to check our charges each and every time here. Aluminum is Al. Sulfate is SO4. Check the charges. Aluminum has a +3. Sulfate has a -2. They don't cancel. So the 2 from the sulfate comes down here, and the 3 from the aluminum goes over here. Al2SO4 taken 3 times. And this is the first time we've seen this, and we need a plus to separate them. They're not joined together, they're just in the same area. Copper 1 oxide. Copper is this, oxide is O. Check the charges. Copper is a +1, oxygen is a -2, and so I gotta put Cu2O. There's my skeleton equation. Hey, if you want to try this one, pause this one, try the next one. Otherwise,
all right, I don't want to run out of time, so I'm going to just pause it right there.
I'm just gonna keep on cruising through here.
All right, so in summary, a chemical equation is a representation of a chemical reaction using chemical formulas, reactants, and products, as well as symbols. Symbols are used in chemical equations and are described and explained. Your review questions, only 4 of them. What does a skeleton equation tell you? Why do you want to know the physical state of materials in a chemical reaction? In a chemical reaction, what does the arrow to the right mean? If I see a triangle over the arrow, what does this indicate?